Okay, hello everyone. Welcome to Daily Math Puzzles. And I've got a nice little puzzle for you today. But before I get into it, let me go over the solution of the last puzzle. So that last one was a really nice one that had a very short solution. Probably a bit tricky to find if you hadn't seen anything like that before. So the problem is you have a non-circular ellipse and you're going to try and inscribe an n-gon, a regular n-gon in that ellipse, so that you put each of the vertices of a regular n-gon on the ellipse. And the problem is to show that that's not possible when n is bigger than 4. So if you have a regular polygon with more than 4 sides, you can't inscribe it on a non-circular ellipse. So if you want to pause the video now, think about it some more, go ahead, because I'm about to reveal the answer. So as I said in my last video, there's something which I would say you should assume to get a short proof of this if you don't know how to show it already, and that is that if you have any circle and any ellipse, then those two curves are not going to meet at more than 4 points. And with that piece of knowledge, you can find a very short proof of this. So basically, the idea is just that we have our polygon here, and we can consider this so-called circumcircle of the polygon. That is, since it's a regular polygon, there's going to be this special circle which passes through all of its vertices. That's called its circumcircle. So the circumcircle of such a polygon, if a polygon had more than 4 sides, then that circumcircle would have to meet the ellipse at more than 4 points. And it's not possible. 4 is the maximum number of points that a distinct circle and ellipse can have in common. So that's the proof by contradiction, essentially. Okay, so here's a nice little problem. The problem is to show, firstly, to show that there is no polyhedron in three-dimensional space which has 7 edges. Okay, and then secondly, we want to show that for every integer m that's greater than 7, we can find a polyhedron which has m edges. So no polyhedron with 7 edges. If we're talking about numbers bigger than 7, we can always find a polyhedron with that many edges. So see if you can find a solution to this. And if this kind of problem interests you, I'd recommend you check out my video on Euler's formula, which has some very nice kind of extra results about this issue of finding polyhedra.